Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Hello dear students, I hope you are doing well. I'm Mr. Mu'adh and this is our chemistry channel. It's called Easy Chemistry for All. It would be great if you can share it with all your friends and classmates so that everyone benefits. Already many students are benefiting from these videos, so that would be great uh, for you and for them to subscribe and share the channel with all the students that you know on social media or your friends and so on. Okay, so we are starting in or we are continuing module 13, mixtures and solutions, from the Inspired Chemistry book, and this is lesson 2, solution concentration part 2.
Here's a reminder about the learning outcomes of this lesson. First of all, we will learn how to solve problems related to the concentration of solutions by performing calculations involving moles and express the results in various units. For example, mole per liter, molarity, mole per kilogram, molality, part per million, percent by mass, and percent by volume. In part 1, we already covered molarity, percent by mass, and percent by volume. Also, we will learn how to prepare practically solutions with specific concentrations by dissolving a solid solute in a solvent or by diluting the concentrated solution. Today's lesson is about solution concentration part 2. We already covered solution concentration part 1 in the previous lesson. So here's a reminder of the main idea. The main idea was that concentration can be explained in terms of percent or in terms of moles. So what I would like you to do now is stop the video and use the knowledge you gained from part 1 to complete the K and the W parts of the KWL chart. What you know about concentration and what you would like to find out. So for the keywords, we already covered the definition of concentration and the definition of molarity in part 1. In part 2, we are going to learn about molality. Molality. It is the number of moles of a solute dissolved per kilogram of solvent. Also, we are going to learn about mole fraction. Fraction. The ratio of moles of a solute or a solvent in a solution to the total number of moles in the solution. Now that we have learned how to calculate the molarity using the equation, we can learn how we can prepare a molar solution with a certain molarity. So, how can we prepare a 1 liter or 1 decimeter cube solution of NaCl that has a concentration or molarity of 0.5 molar? So how can we do that? So the first step that we need to do is to calculate the mass of the solute or measure it, all right? Because we don't have a balance for moles, we have a balance for mass. So the first thing that we need to do is find the moles of the solute using the equation of molarity, because we have the liters and we have the molarity. So using this equation, all right, we can find the moles of NaCl, multiply the volume by molarity. And now we can multiply the moles by the molar mass to get the mass of NaCl. And the mass of NaCl is 29.25 grams. Now we can weigh this 29.25 grams of NaCl, and after that we can place it in a volumetric flask with the correct volume, a 1 liter volumetric flask, add a little bit of water, dissolve it, and then keep adding water until we reach the 1 liter mark, because now we have a solution of 1 liter. Let's check your understanding. So here's a quick fire question. Which procedure or technique is correct for preparing a 0.5 gram NaCl solution of 1 liter? Is it adding 1 liter of water to 0.5 grams of NaCl? Or is it adding 0.5 liter of water to 0.5 gram of NaCl and then keep adding water until it reaches the 1 liter mark. Which one is the correct one? You can stop the video and think about it. All right, so as we explained in the previous slide, the correct answer is going to be the second one, because the total volume here is going to be 1 liter. But imagine if you add 1 liter to a 0.5 grams, so it's going to be larger, or the volume is going to be larger than 1 liter. So we are no longer in the 1 liter. There is another way in which we can prepare solutions with certain molarity, and that is diluting molar solutions. Here's an example. Your chemistry teacher challenged you with this question during the molarity lesson. How would you decrease the concentration or dilute a stock solution of 4 molar NaCl to 2 molar NaCl? You can stop the video, use the hint, and try to answer the question. All right, thank you for your efforts. So let's begin with the equation. Molarity equals moles of solute over liters of solution. So we know that these two relationships are there. The molarity is directly proportional to the number of moles and indirectly proportional to the volume. So if we reduce the number of moles of NaCl, we will lower the molarity. And if we add more water, we will lower the molarity because we will have more volume, right? All right, keep this in your mind, especially the second point. And let's watch the video.
We often prepare a solution of a given concentration by diluting a more concentrated solution. The addition of water to a solution reduces its concentration, but does not change the number of moles of solute. The number of moles of solute before dilution is the same as the number of moles of solute after dilution. Molarity is defined as the number of moles of solute divided by the volume of the solution. Hence, the number of moles of solute is the product of molarity and volume. Since both solutions, the concentrated one and the dilute one, contain the same number of moles of solute, we can calculate the molarity of the dilute solution from the relationship Psi1 V1 equals Psi2 V2.
All right, so this is the relationship that we get from the video. N1 equals N2. So we can use this relationship to figure out how much of water do we need to add to reduce the molarity. Let's solve an example on the equation that we studied in the last slide. So, how much water should be added to 125 centimeter cube of a 1.2 molar solution of KOH, potassium hydroxide, to obtain a 0.5 molar solution of KOH? You can stop the video here, try to fill in the gaps, and try to find the final solution. Okay, thank you very much for your time and effort trying to answer this question. So let's do it together. So this is a dilution problem because you have volume and the concentration and then another lower concentration. So you know you are going to use this equation, okay? So C1 times V1 equals C2 times V2. So let's fill in the parts of the equation. So what is the first concentration, or C1? It's given to you here, 1.2, all right? And what's the volume, or V1? 125 centimeter cube. You put it here. It's going to equal, what is the second concentration, or the new concentration that you want your solution to have? 0.5 molar multiplied by V2, which is the unknown. We don't know it yet. So try to find V2 using your math skills. So here you have 1.2 multiplied by 125 over 0.5, and the answer is going to be 300 centimeter cube. Did we finish the question? No, because the question is asking you how much water should be added to. So this is the final volume, but how much should I add to 125 to reach 300? It is simple. Just subtract volume 1 from volume 2. So the volume of water that I need to add is going to be V2, which is 300, minus V1, 125, and that is going to equal to 75 centimeter cube. Is that correct? No, it's going to be equal to 175 centimeter cube. So far, we have discussed 3 ways to calculate the concentration using mathematical methods. The first one is percent by mass, the second one is percent by volume, and the third one is molarity. Now, in ideal solutions, we will be using molarity, but sometimes we have changes in temperature, and that affects the volume. So what would happen to the volume when the temperature increases? Usually, the volume is going to increase, right? Because when the temperature increases, the distance between atoms increases, and thus the volume increases, right? So the molarity is going to decrease. In order to avoid such problems, we use, or chemists use, another way to find concentration, and that is molality. It's the ratio of the number of moles of a solute dissolved in 1 kilogram of solvent, and we find it using this equation. Molality equals moles of solute over kilograms of solvent. Pay attention here, it's kilograms of solvent, not solution. Okay, so here's an example. What is the molality of a solution made from dissolving 0.5 mole of CaCl2 in 500 grams of water? So you know the moles of CaCl2 and the mass of water, and you don't know the molality. So if you write down the equation, molality equals moles over the mass in kilogram, just plug in the numbers. So it's 0.5 mole of the solute, CaCl2, over 500 grams of the solvent, which is water. But we need it in kilograms. So we convert the grams into kilograms by dividing by 1000. And finally, this gives us the solution as 1 molal, or 1m, referring to the molality. The final method we use to calculate concentration using a mathematical method is using the mole fractions. So if you know the moles of a solute and a solvent, you can express the concentration of a solution using the mole fractions. And here's an example. So XA, or a mole fraction, which is X, the mole fraction for substance A is equal to Na over Na plus Nb. So the moles of the solute over the moles of the total solution. Okay? And similarly here, if I have B as the solvent, so the mole fraction of the solvent is going to be moles of solvent over the total moles of the solution. Okay? So here's an example. A solution of HCl is made from 0.99 mole of HCl, the solute, and 3.6 mole of water, the solvent. Find the mole fractions. So we have 2 substances here, all right? We have HCl and we have water. So we just use the examples here. So the moles of HCl over the moles of HCl plus the moles of water is going to be 0.99 over 0.99 plus 3.6. So the mole fraction of HCl is 0.22. And if we do the same for water, we will get 0.78. If you add both, you will find that it results in 1. So that means that 0.22 of the moles are for HCl and 0.78 of the moles are for water. Let's revise the concepts that we studied using true or false questions. So, a diluted solution of NaCl contains more solute than concentrated solution of NaCl of the same volume. And the correct answer is false, because it should contain less solute. Concentration can be described qualitatively and quantitatively, numerically. That is true. Molarity is defined as the moles of solute that are dissolved per liter of solvent. You might think it is true, but it is false because we said per liter of solution, so this is wrong. Molality is used to calculate concentration because temperature alterations can affect molarity. That is true because temperature affects volume and molarity depends on volume. Finally, the sum of mole fractions of a certain solution must equal to 1. That is true, as we have seen in the last example. We have reached the final summary of part 1 and part 2 of solution concentration. What I would like you to do now is to try and fill out the L part of the KW chart. It is about what you have learned. Alright, thank you very much for your efforts. So, we have covered the following in part 1 and part 2. Concentrations can be measured qualitatively and quantitatively. Molarity is the number of moles of a solute in 1 liter of solution. Molality, small m, is the number of moles of solute dissolved in 1 kilogram of a solvent. Finally, the number of moles of a solute does not change in a dilution process.